Welcome to 7.5 Part 2 Operations with Matrices, and the Part 1 is just a short little 17-minute video. This is going to be a little briefer than that even, so let's go ahead and get started. The problems 60, 62, I like them a lot, but I like them in a state that they're actually being used in the next section. They're going beyond. This is just kind of a warm-up for us. And a little bit confusing, simple, but a little bit confusing to get started on these. The first thing they ask us to do is perhaps the confusing part. Write the system of equations as a matrix equation, AX equals B. And we learned yesterday if we've got capitals here, capital letters, those are all matrices. So I need a matrix times a matrix equals B. And what I notice, our multiplication that's occurring is 2 is getting multiplied by x1, and 3 is getting multiplied by something, and 1 perhaps is getting multiplied by something, and 4 is getting multiplied by something. So this 2, 3, 1, and 4, it's tempting to make those be a matrix. And if I do that, the matrix I want to multiply those by, here's the deal. This I call it the twisty finger thing. I didn't make it big enough here, but we're going to take 2 and 3, rotate those and multiply them by values here, and so it's going to look like this. 2 and 3 are going to turn and be multiplied by, well, I want the 2 to be multiplied by x1, and I want the 3 to be multiplied by x2. So it's tempting to call this x1 and x2. And let's see what we get here. 2 times x1, 3 times x2, good, and then I'd get 1 times x1 plus 4 times x2, and this is first row, first column, second row, first column, so this is going to be the 2 by 1, 5, 10. And then in the next section, section 7.6, I believe it is, I may be wrong, might be 7.7. The next section, they're going to have us extend and do some more with this guy talking about inverse matrices. But anyway, this is sort of just warm up, because if they'd have asked us to just solve this using Gauss-Jordan, we'd already be done in the time we talked through that. It says use Gauss-Jordan elimination with the augmented. To augment something means to add to it, to supplement it, to embellish it. Well, the augmented matrix, A augmented with B. Oh, okay, so that is 2, 3, 1, 4. Here's matrix A times matrix X equals matrix B. I want to augment that with B. Well, that's exactly what we'd do if we were setting this up to use Gauss-Jordan elimination. Now, you could solve this. What you might do is flip-flop the first rows to get that 1 in that lead position that I talk about, but I'm going to leave it the way it is. I'm going to multiply this row by -2, and there's my hired hitman. I'm going to go down here and whack that guy after it becomes -2. Looks like this. So the hitman row never changes. 2, 3, 5. Touching, I get -2 and 2, 0. I get -8 and 3, -5. I get -20 and 5, -15. And I'm going to divide this row by -5 right here. So we get 2, 3, 5, 0, 1, 3. Next hitman, multiply this row by -3 and send it up. And we get touching 0 and 2, -3 and 3, -9 and 5, -4, 0, 1, 3. Divide this row by 2, and we've got 1, 0, -2, 0, 1, 3 for an XY ordered pair solution of -2, 3. And again, to be honest, I might not even use Gauss-Jordan if I was going to solve this. I might just multiply the second row by -2, add them. Gauss-Jordan becomes really useful for 3 by 3s, and boy, if you're solving 4 by 4s or 5 by 5s by hand and above, way, way easier than the process of elimination. I mean, Gauss-Jordan is elimination, but it organizes it for you, and you don't have to keep writing X, Y, Z, W, all of that. Okay, so 62, same thing, a little less friendly solution, but not too bad. we have a coefficient matrix A, -4, 9, 1, -3, times our variable matrix X, which is x1, x2. And a good question would be, why do they use x1, x2? Some of you will pursue mathematics to the depth you get into a linear algebra course where they have multivariable systems, and there might be 15 variables. And rather than just name them A, B, C, D, E, F, etc., they just name them x1, x2, x3. So it's easier to ask for, hey, I want to know what the eighth variable is, x8, rather than having to say, oh, the eighth variable, eighth letter of the alphabet, that's H. Anyway, that equals our solution, -13, 12, much like in number 60. So now we augment -4, 9, -13, 1, -3, 12. And if I said Gauss-Jordan, we would have just gone straight to there. Just like last problem, you might be tempted to multiply or to flip-flop the rows. I'm just going to multiply the second row by 4 and send this -4 down to whack that. So we get, Hitman row doesn't change, never does. Touching 4 joined with -4, 0. -12 joined with 9, -3. So far, so good. -13 joined with 48. Ouch. 35 would have been nice if that reduced by 3. However, the -3 is really useful for eliminating this 9. Going to multiply by 3 and send it up. Touching 0 and -4. -9 and 9, 0. That's why we're doing it. Yuck. 105 minus 13, 92. 0, -3, 35. I'm going to divide by -4. I'm going to divide by -3. And we get 1. 0. Positive divided by negative, negative. 92 divided by 4, 23. Divide by -3 and I get 0, 1, and nothing great happens here. -35 on 3 for an ordered pair solution of x is -23, y is -35 thirds. Oh, sorry about that. I had you off the screen a little bit and never looked back to see it. Anyway, hopefully you caught that as we were going through. Pretty simple to get from here to there. Okay, now on the previous section I talked about the process of multiplying these, and we've repeated that here. It's kind of that twisty finger thing. It's kind of a weird deal, and people had asked why do we multiply things like this? And it's more than just a arithmetic process for us. There's actually a reason to do it. So let's take a look at 87. Great problem. A fruit grower raises 2 crops, apples and peaches. Each of these crops is shipped to 3 different outlets. The shipment levels are represented by A, and these are just units of apples. They're talking about units down here. So we got our apples, our peaches, our outlets, and you can see why it might be nice to organize this in a matrix. Imagine this. Imagine there's a hardware company that makes 150 different sizes of screws, and they send those to 500 hardware outlets. And how are we going to organize that? Well, we're going to put it in an Excel spreadsheet or Google Sheets or something like that. And all of those things are just matrices. The tough thing to get our head around here is some of what we do like this, there's easier ways to do it than to go to a matrix. But boy, as soon as you get to, let's say, just a 30 by 30 or just a 5 by 5 system, way easier to go through some processes we're learning here. So we're just working in a really finite little domain problem here. But we're going to see why we multiply the way we do. A grower earns $3.50 for each unit of apples and $6 for each unit of peaches. Organize the profit per unit of each crop in matrix B. Well, matrix B could either be perhaps $3.50 and $6, but I also might put it into $3.50 and $6 like that. I don't know. I'm not crazy about question A. They should say organize the profit per unit of each crop in matrix B so that you can multiply B times A. Okay, now multiplying B times A, take a look. Here's the little twisty finger thing. this times that works, and these two times this works. Another way we talked about that is here we've got a 1 by 2 times a 2 by 3. The 2's match so we can multiply them that way, and we're going to end up with a 1 by 3. But if I did twisty finger thing here, I'd take 350 and it had to be split between 125 and 100. Doesn't work. That's a 2 by 1 times a 2 by 1 times a 2 by 3. These don't match. We can't multiply it. So there's our choice for question A. We organized B, and now we can take B times A. So I'm going to go 3.56. There's B times A. 125, 100, 75, 100, 175, 125. Let's double check. Yeah, feeling good about that. So I'm going to label all of these things. This is outlet 1, outlet 2, outlet 3. This is apples, and this is peaches. And find the product BA. Easy enough, and we can do that without calculator, but we're going to do it with calculator. And interpret the result. Well, let's just go ahead and go through the process of finding this on our calculator. So I'm going second matrix as we've done before. I'm going to edit this first matrix, and I'm going to change that to be a, that's matrix A, and this is one that they referred to as matrix A here. So I'll call this matrix A. This is going to be a 2 by 3, and the entries are 125, 100, 75, 100, 175, and 125. Second quit, second matrix. Let's edit matrix B to be a 1 by 2, 3.5 and 6. Second quit. And let's go back and grab matrix B first. It matters, order matters. B times matrix A. And we get 1037.5, we get 1400, and we get 1012.5, and all of that's simple enough. I should make that a matrix. But what does it mean? What does that mean to us? Let's take a look. I'm taking $3.50 times 125, the number of apple units in outlet 1. I'm taking $6 times 100, the number of peach units in outlet 1, and then I add those together to get this. This is the total. This is total profit in outlet 1. Likewise, total profit outlet 2, total profit outlet 3. So there is a reason why we'd multiply matrices in this twisty finger manner that I talk about. So this is total profit in each, or at each outlet. It organizes it for us like that. And the beauty of that is, go back to the hardware manufacturer, hardware stores, where we have thousands and thousands of elements in here. Excel, and I'm certain Google Sheets as well, they have a command to multiply these rectangular arrays or these matrices, and just enormously powerful process where even entering it here would be, imagine that example having to enter it here, but this is really preparing us for spreadsheets with much bigger sets of data. Keep that in mind, because a lot of these things would be, well, this would be so much simpler just to kind of work it out, jot down a sketch of what's going on. But really good stuff. A lot of opportunity in the age we live in now, because there's just so much data, and to try to work through data, being able to work in matrices gives us a real heads up on that. So anyway, here's our homework assignment, and pick up a homework sheet from me and let me know what I can help you with. As always, good luck.